Hello everyone, and welcome to Biopedia. Today we're going to discuss a concept which several of my sources say is equivalent to sibling species. This is the idea of cryptic species, with the prefix crypt being from the Greek and referring to something being concealed. We will be asking the question, do these two terms mean the same thing? Along the way, we will also look at some examples from my sources. Now, Wikipedia maintains that there is a subtle distinction between cryptic species and sibling species. They claim that sibling species refers to species which are closely related, while cryptic species are those which are different but are lumped in under a single taxonomic designation. My sources have defined cryptic species as 2+ organisms that cannot be separated from each other by their looks or by traditional taxonomy. Nonetheless, these species cannot produce viable offspring together. They can be very different in terms of how they sing, their ability to withstand low water levels, etc. The term cryptic is a good fit because, if you were to just look at appearances, you wouldn't think they were separate species, but instead that they were one and the same. In other words, the separation is hidden by traditional methods of classifying species. A quick example of this would be crickets in Northern America, with frequently the sole factor distinguishing them being their song. Now that we have a definition of cryptic species to work with, is this the same thing as sibling species? I went back through my notes from episode 47 where we discussed sibling species, and in it I do emphasize the fact that sibling species are those which are distinct, but do not appear to be at first glance. In other words, pretty much the same definition which we've given here. However, that's not the end of the story. A review paper from 2007 highlights a split in the literature between those who treat the two terms as synonymous and those who say that denoting sibling species implies those species have a more recent common ancestor than simply cryptic species would. The authors drew a line in the sand by saying that cryptic species should be species which had in the past been lumped together taxonomically speaking. They sided with the idea that sibling species should imply some form of relationship, as it was more useful as two separate terms than as one. I suppose I can see the use of this viewpoint. After all, having more tools in your toolbox and leaving less room for ambiguity is a good thing. Let's look at the phytoplankton lineage Pseudonychia to get another real-world example in. Pseudonychia create algal blooms which can be dangerous on the west coast of North America. In the past, this group was divided based on appearance, as we've seen previously with this concept. A study from 2007 looked at two so-called morphospecies, i.e. species identified based on morphology, to check whether two very similar morphospecies really were separate or should be lumped together again. The study used more powerful electron microscopes rather than light microscopes in order to do a more thorough visual check, as well as making genetic phylogenies. This basically allowed them to attack the problem from multiple angles. In the end, the study found that the two morphospecies should actually be separated into 8 separate species. One of the morphospecies had 3 separate genetic lines within it, with 5 being present within the umbrella of the other. This result came back regardless of which so-called species concept was used. In other words, the approach didn't matter. Now, why is this important? In this case, because the production of neurotoxin varies wildly within the Pseudonychia family tree. As such, having an accurate understanding of its phylogeny is important, with the potential to impact health of humans and the functioning of the ecosystem. I'll leave you with the results of yet another 2007 study which examined the database of something called the Zoological Record between 1978 and 2005. The aim was to see how often cryptic species were reported among metazoans. They discovered 2,207 cryptic species reported in the database during the course of their systematic search, and concluded that the number of cryptic species likely did not differ between taxa or between locales, with there likely being an even spread of cryptic species throughout metazoans. The point I'm making in this episode is that biological terms can be fluid and subject to change. Even I started the planning for this episode thinking that the two terms were synonymous. What I've managed to gather from my research, even if it might not be the whole picture, is that there is at least a faction within ecology trying to get the two terms recognised as separate. That's it for today. As always, thank you for listening. If you have any questions, comments, or topic suggestions for future episodes, you can get in touch with me at the show's email address. Until next time, have a great week, everyone.